example 2, we're going to look at how to find the integral between two curves when limits are not given. As in this example, we're trying to find this region in here between these two curves. So notice that these two curves intersect right here at point A and at point B down here. This is actually how we're going to determine our limits, is by evaluating this x-coordinate and this x-coordinate. The idea here is that we're going to shrink down the y-axis and integrate between these two a and b x values. Now, of course, the graph still exists like this, I just made the window different. Areas enclosed by intersecting curves. When a region is enclosed by intersecting curves, the points of intersection give the limits of integration. So what we're going to do is we're going to go ahead and solve for this a value and a b value in order to determine our limits of integration. So in example 2, we're going to determine the area of the region enclosed by the parabola y equals 2 minus x squared and the line y equals negative x. Now step 1 is to graph the curves. So go ahead, take a second on your graphing calculator and graph this out, or you can do it by hand and sketch it below. Now if you sketched it, you should get something that looks like this. And my graphing calculator and my program will determine my x values for me, but I want to show you how to do it by hand. So notice that this top graph here is y equals 2 minus x squared, and the bottom graph here is y equals negative x. I also find it very helpful to label the two functions, and so it makes it easy for me to see which one's the top and which one's the bottom. Step 2. Determine the intersection either algebraically or using a calculator. And so the way that we do this, in order to find the x values at which these two functions intersect, we're going to set each function equal to each other and solve. So you get 2 minus x squared is equal to negative x. That's because this equaled y and this equaled y. So when you set them equal to each other, the y's go away, and now we're just going to solve. So we get 0 is equal to x squared minus x plus 2, and then we go ahead and factor, and you get x minus 2, x plus 1, and so 0 is going to be equal to x minus 2, and 0 is equal to x plus 1, so x is 2, and x is negative 1. And so these are our limits. Now the question is, which one's A and which one's B? Well, this one is going to be A, and this one here is going to be B. That's because when we read a graph, we read it from left to right. So step 3 is to actually set up the integral and solve. So we're going to get the integral from negative 1 to 2 of our top function, so f of x, which was 2 minus x squared, minus the bottom function, negative x. And we're going to integrate along the x-axis. That's why we solve for the x-intercepts. If we want to solve for the y values of the intersection, then we'd integrate on dy. But that's just a little bit different, but we'll do that later. So this becomes the integral from negative 1 to 2 of 2 plus x minus x squared dx. And now all we have to do is integrate. Again, if you have a calculator and this is a calculator portion, then just go ahead and plug it in the calculator. But it might come in the non-calculator portion, so we need to do it by hand. And so here we go. And so now what we're going to do is we're going to integrate. So you get, this is 2x plus x squared over 2 minus an x cubed over 3 from negative 1 to 2. And if you had a calculator, again, you just plug it in. But we're going to do it by hand. So you get 2 times 2 plus 2 squared over 4 minus 2 cubed over 3 minus 2 times negative 1 plus negative 1 squared over 2 minus negative 1 cubed over 3. So now we're just going to work it all out. Made a slight typo. This should be a 2 right here, not a 4. So this is 4 over 2 minus 8 thirds minus negative 2 plus 1/2 plus 1/3. And now what I'm going to do is I'm going to find common denominators for everything. So I get 24 over 6 plus 12 over 6 minus 16 over 6. And I'm going to go ahead and do the same thing here. I get negative 12 over 6 plus 3/6 plus 2/6. And you're welcome to solve this however you like, as long as you get to the right answer. So this is 20 over 6 minus negative 7 over 6. And so you get 27 over 6, which is equal to 9/2 units squared. Now on your own, I want you to determine the area of the region between the curves x equals y cubed and x equals y squared. My hint for this one is to solve for y to get the intersection points. So here we go. We have x is equal to y cubed. So in order to solve for y, we take the cube root of both sides. And you're going to get y is equal to the cube root of x. And for the other one, we get x equals y squared. So we take the square root of both sides. And normally you need a plus or minus, but we're going to end up being in the positive region, so we'll be okay. And so y is equal to plus or minus square root of x. And if you graph those, you'll get something that looks like this. So obviously this is 0, 0. And it looks like this is 1, 1, but we're going to evaluate those just to make sure. This bottom graph is y equals the square root of x, and the top graph is y equals the cube root of x. So now we're going to go ahead and solve that. So we're going to get the cube root of x is equal to plus or minus the square root of x. Now I like to write these with fractional exponents. It makes my life a little easier. And now what we do here is we're going to raise both of these to a power. My goal is to get rid of fractions. So if I raise both sides to a 3, I'll get rid of the fraction on the left but not on the right. If I raise it to a 2, I'll get rid of it on the right but not the left. So I'm actually going to raise both sides to the 6th power. And this is going to leave me with x, 6 times 1/3 is 2. And then x, 6 times 1/2 is 3. Now what we need to do is solve this. So you get 0 is equal to x cubed minus x squared. Factor an x squared out, and you get x minus 1. So x is equal to 0, and x is equal to 1. So we were right with our x values. These are our limits, where this one is a, and this one is b. Now we just got to do some simple integration and we'll be good to go. So we're going to go ahead and integrate from 0 to 1. Our top function is x to the 1/3, and our bottom function was x to the 1/2. And we're going to integrate that along x. So now we integrate, and we get this is x to the 4/3 times 3/4 minus x to the 3/2 times 2/3. And this is from 0 to 1. So we get 3/4 times 1 to the 4/3 minus 2/3, 1 to the 3/2 minus, well, this whole thing is going to be 0. Because I plug in 0, I get 0. So this is 3/4 minus 2/3. Again, finding common denominators, we get 9 over 12 minus 8 over 12, which gives us 1/12 units squared.